Hello, welcome to JULES tutorial number 3. We're going to expand on the previous experiments we did, and this time we're going to look at what happens when we change the vegetation model. So previously we were just using a static vegetation, which means that the vegetation basically stays the same throughout the year. Just to try and make this following experiment a little bit more consistent across the different permutations we try, I'm going to up the spin-up cycles to 20. And basically my first control run is just going to be as we had before. In fact, now let's come in here and do some more sensible things. We'll set up this run so it's a little bit more like something you would do. So what have we got here? These are the vegetation things we're going to look at later. There's a few things like this fix here. We're actually using CAN-RAD6, which is correct already anyway, but let's turn on the fix. There's a stem respiration fix. There's allow conduction in the soil below the vegetation. Let's turn that on as well. Let's put some trait-based physics because they're a bit better representation of vegetation. We don't get our V-box, we don't have any ozone data. Irrigation, we're going to ignore. These CAN-RAD models and canopy models are the best options, 4 and 6. Number of layers 10, that's the number of canopy models that we're modelling. JULES fix, yeah, we're going to be sticking Triffids, so let's stick that on now. We'll ignore crops and the fire model. We'll just stick with the standard soil moisture, vegetation function. Scale rest, I will put that on as well, why not? Save all those and just check everything's okay. What other options can we play with here? Let's just leave those as they are. Top models on. Oh, that's interesting. I'm going to turn top model off for this experiment. Right, okay, so we've got a basic model going. It's very similar to what we had before. Our output's now called static vegetation. We've got 20 spin-ups. Let's hit play. I'm going to hit pause and restart once the model is finished going. Okay, so our static vegetation run has just completed. We're going to do a permutation 1. We're just going to turn on the leaf phenology. So this allows the JULES to grow the leaves on the trees and on the grass and during the run. So we click tick and it immediately tells us that we need to do something else. This is the phenology period. That's how frequently the phenology model is called. I'm just going to put that onto 1 day. That's sometimes you make a compromise for computational purposes, but we're just running 1 point, so doing it every day is fine. We click the save button, as I probably said in the previous video. The save button is the check everything's okay button as well, and it's telling us something is wrong. What's it telling us is wrong? So figure out what it is here. It's nameless JULES initial, so it's the initial conditions. There's a type of error, and here it tells us LAI must be given if L_phenol equals true. And that means that we come here and we go, okay, so we need to provide it with an LAI value. We add a value, a variable to include in the initial conditions. We scroll down until we find the one we want, LAI, and then we have to give it some sort of sensible first value, which I'm going to put as 3. So that'll give all the vegetation types that we're modelling a value of 3. So that's good to go. I'm going to hit, oh wait, no, we want to change the name, and we'll just call it phenol vegetation. Save, check everything's okay, hit play, and I'm going to pause until that. Alright, so our phenology run has completed. We're now going to do a third factorial experiment, and we're going to turn on Triffid, which is the dynamic vegetation model. Dynamic vegetation model basically allows the vegetation to grow, and if we turn on the competition it'll start competing, so it's basically one up from just having the leaves growing, the actual tree and stem starts growing, and it feeds the soil carbon pool as well, which will affect the soil respiration and things like that, and the methane emissions if you start looking at those things. I'm not going to turn on the veg competition yet. We're just going to start off with just turning on Triffid. We also have to provide it with a Triffid period, which we're just going to have as one. We click there, is everything okay? But then we get two error messages, one regarding the soil biogeochemistry and one regarding the initial conditions, which again, this time it's asking for canopy height. It needs to know how big the trees and stuff are when we start this runoff. Okay, so the soil biogeochemistry, we'll stick this onto Roth-C. The single pool model is only valid for non-Triffid runs. We have these two options, Roth-C and ECOS. You can read more about those in papers online. ECOS isn't actually ready yet, it's just a placeholder really, or an untested model so far, so we'll stick with Roth-C. And we've got warning messages at the, we need to add the canopy height, so canopy height is there. We'll change that to 3 meters to start off with. We'll click the save, and is everything okay? But everything looks okay, so we'll hit play. And I'm going to pause it until that's completed. So our final vegetation variation simulation has been completed. So we've got our 3 vegetation variations all run and simulated, and now we're going to run my little JT-plot multi-script, which is in the rows suite directory, and this time we're going to give it the names of our different permutations of the vegetation options. And if we just click go, so we have the static vegetation in blue, we have phenological vegetation in green, and we have Triffid dynamic vegetation in red. There are small changes that aren't very observable to the fluxes of water vapor and latent heat. Tiny changes to the soil temperature. I think we're just looking at the surface layer here, which will be mainly dictated by the air temperature which we're prescribing. But the soil moisture, you can see that actually with the phenological vegetation there's a little less soil moisture, but with the Triffid vegetation there's more soil moisture, which implies a reduced evapotranspiration when we have dynamic vegetation. Can't tell you exactly why, but interesting. And another example of a quick experiment you can do with rows suite.